All right, I want to do a video on the Chapter 4 material, just kind of a good review of that. So what I'm going to be doing is using problems off of the review for Chapter 4 that I passed out in class last Wednesday. So you can go in here to our Blackboard course, go to course documents, and there you'll find the review and also the answer key for the review. Okay, so if you haven't yet, pull that. If you don't have a copy, pull that up. That's what I'm going to be using as I do this review. Okay, so when I refer to a question number, that's what I'm referring to. All right, so in sections 4.1 and 4.2, that's where we cover exponents. So you know what a positive exponent is. Then we did things like that some number raised to the 0 power would be 1. If you had a number raised to a negative exponent, that means 1 over 3 squared. And that if you had negative exponents, say, on the top and the bottom, that if you have a negative exponent, when you move it to the other side of the fraction bar, it becomes a positive exponent. It's like you're taking the reciprocal, and the ultimate result would be that the 4 to the 5th would be on top. The 3 to the negative 2 could move to the bottom and become 3 squared. So part of your job on these exponent problems is going to be to get them simplified, and that's going to mean that your final answer can't include any negative exponents, okay? So I think you'll be okay on the first 3 once you see the answers. I just wanted to work a few others. So this one right here is actually question number 4 from the review. Okay, and so it's just reminding you that 3 to the negative 2 means 1 over 3 squared, and then 3 squared is 3 times 3, so that would be 1/9. Okay. When you look at question number 5, it involves the 0 exponents, but you have to be careful about what the 0 is getting applied to. Okay, so because 0 is being applied to the 13, that's 1, and because of these parentheses, the 0 is being applied to the negative 2, so that becomes 1, and that would turn out to be 2. But what if this were written slightly differently? What if you had 13 to the 0 power plus, and here, what if you had negative 2 to the 0 and the parentheses were like that, not between the negative 2 and the 0? Well, then the 0 is only getting applied to the 2 in that case. And so this would wind up being negative 1. 13 to the 0 power would be 1, and you'd wind up with 0. So that was a what if. That wasn't what the problem number 5 really was. But as you do a review, you've got to be thinking about things like that. I can't put every possible type of question, so you have to be remembering things of that nature. And then this one I put because I wanted you to be sure to understand that the negative out in front doesn't cause you to do 1 over. That's just a negative number. That just means negative 1 times 6 to the 3rd. So you do 6 times 6 times 6, and that turns out to be 216, and then take its opposite. See, the base on this is 6, okay? The base there was negative 2. The base there was 13. Over here, the base was just 2. Okay, here it was 13. And so because the base was just 2, the exponent applied only to the 2, then you brought down the negative. Okay? All right, so some of those basics can be pretty tricky. All right, I think you'll be okay on number 7. Just be sure when you do that that you put parentheses around them when you plug in. I'll go ahead and do it real quick. So there you were supposed to be replacing the x with a negative 2. Okay, so you had negative 5 times negative 2 squared plus 5, and then times x, which would be negative 2 in this case, and then plus 6. Okay, and you're just supposed to evaluate that. So you got to watch order of operations. You got to do this first. That'd be positive 4. Okay, 5 times negative 2 would be negative 10. This would be negative 20 minus 10 plus 6. That would be negative 30 plus 6, which would be negative 24. Okay. All right, now we're getting into the problems where you're going to be using some of those rules of exponents. So here's where you want to remind yourself which one of these becomes to the, which one of these becomes to the 6th power and which one of these becomes to the 5th. So you have to have a way of reasoning that out in case you get mixed up. So this just means x times x. X to the third means x times x times x. And so you actually have x to the fifth. So the shortcut on that one is to add them. See how there's an x again? In both places, you're multiplying the powers that have the same base. Here, the power is being raised to the third power. The shortcut there is to multiply, because the 3 tells you to take x to the second times itself 3 times, and then each of those are an x times x, so you wind up really having x to the 6th power, okay? Let me see if I can get another page. All right, so let's go ahead and do a few of these problems. And you've got answers to some of them, so you can do some of these. I like to do a lot of the exponent ones, though, because that's where people typically have the biggest issue. So you should try all of these before you look at my video. Okay, so like this one. This is number 8. I'm going to do a bunch of these, but I really want you to have tried these problems before you watch the video. So if you haven't tried them yet, you take a moment to do that. So see, this parenthesis really isn't between the p and the exponent. So the 4 only goes to p, the 6 only goes to p. The parentheses here are really just indicating that these two expressions are getting multiplied. Let me see if I can write that here. So this is -6 times p to the 4th times -2 times p to the 6th. That's really all you got going on. So that would be 12, and this would be p, and you got to be careful. It's going to be p to the 10th, because you just have 4 p's here and 6 p's here, and they're all just getting multiplied together, okay? So you just have a string of 10 p's, and then that would be your final answer. All right, now on number 9, you have parentheses around that. So the 3 only applies to the x, but the 2 applies to everything, okay? So you got to raise the -4 to the 2nd power. Then when you do x to the 3rd raised to the 2nd, that's going to become to the 6th. And then y would be to the 2nd power. Then all you got to do to finish it is work out -4 to the 2nd. And that's a negative on the number part, not on the exponent. So that's just -4 times itself. That's just 16. It's not a matter of moving to the other side of the fraction bar. All right, let me go ahead and do number 10 over here. 10 looks easy, but this is one that a lot of people miss when I do it. The way I want you thinking about it is, I want you seeing 3 t's on top and 7 t's on the bottom. So 3 of those are going to cancel out, and you're going to have that many t's left, and see how they're on the bottom? So when you write your answer, make sure you do 1 over t to the 4th. That is not the same as t to the 4th. Okay, so you'll miss a lot of points if you do that. All right, now we're getting into the problems. Let me do one more here that's short. Let me skip to number 12, and then we'll do the others when I have more room. So on number 12, we have 3p raised to the -4th power. So this is the one I keep using as an example, this type, because only the p is being raised to the -4th power. The 3 has an understood 1 on it. So when you think about getting rid of the negative exponent, the 3 should stay where it is. The p should move down and become p to the 4th, and then that's as good as it gets. Okay. All right, and then problems like 11, 13, and 14. Let's go ahead and look at those. Let me get 13 out of the way first, and then we'll do 11 and 14. All right, so on 13, this one's a little odd to students because there's no variables. But 8 is actually the base on each of those. So what you would do there, or should do there, is just the way we approached them all. If you have a negative exponent, you can move the power to the other side and make the exponent positive. So 8 to the 3rd would be on top, and then 8 to the 2nd on the bottom. 8 to the 6th would stay where it was because it's already positive. Then rather than working each of these out, I think it would be good for you to realize you've got 3 8s multiplied together, 6 more 8s. See how that would be 8 to the 9th on top. It'd be 9 eighths multiplied together. Down here you have 2 eighths. So you could get rid of 2 of the eighths on top and you'd be left with 8 to the 7th power. Okay. And then a lot of times that'll be okay as your final answer because 8 to the 7th turns out to be a really big number. So we're just going to leave it in exponential form. Okay. All right. So now I'm going to go back and look at 11, which looks messy but has all positive exponents. Then we'll look at number 12, which looks similar to it and has negative exponents in it. Got to make sure I get it copied with the parentheses and everything where they need to be. Yep, that one's good. Number 11. And then x, y to the 3rd. Okay. All right, so let's work 11. So I want to get rid of the parentheses. And so basically I'm doing 2 to the 3rd. Then when I do x squared raised to the 3rd, that's the situation where the exponents would be multiplied. Then y, which is understood to be to the 1st, raised to the 3rd would be y to the 3rd. Okay. Then the x is understood to be to the 1st, but then it's raised to the 4th power. So it becomes to the 4th. These would get multiplied. You'd have y to the 12th. And then see how the x, y is in parentheses to the 3rd power? So the 3 and its multiplication there, the 3 gets applied to each of those. Okay. All right, now what I would recommend you do next would be to get things simplified. So like in the denominator, you can't put those together. They have different bases. There are no other numbers other than 2 to the 3rd, so you might as well go ahead and work that out. That would be 8. But then on top, do you see the x to the 6th and the x to the 4th? Those have the same base. So if you had a strip of 6 x's and then 4 more x's, that would be 10 x's multiplied together. And then 3 y's, 12 more y's, that would be y to the 15th multiplied together. All right, and then the last thing I'm going to do is I'm going to look at how I've got 10 x's on top and 3 x's on the bottom. So that means I'm going to be able to knock out 3 of the x's on top, but there'd be 7 left up on top. And I can knock out 3 of the y's, so there'd be 12 left there, and nothing was left in the denominator. So that would be your final answer on number 11. Okay. Now, number 11 had all positive exponents. So there you really just had to think about when it was appropriate to multiply your exponents and when it was appropriate to add them. All right, so we're going to approach number 12 in a similar way to start with. We're going to get rid of the parentheses, which means our exponents get multiplied. So this would be x to the 21st. Here we have an understood 1 on the y. That is being raised to the 2nd power. So I'm going to have x to the negative 2 and then y squared. In the denominator, the x is raised to the 1st power right now, and that is multiplication. That's being raised to the 2nd. So that exponent of 2 applies to both of those. And when I remove it, it's going to wind up being multiplication that I use. So 1 times 2, that would be x squared. Negative 7 times 2 would be y to the negative 14th. Okay, and then the next step I was proposing you do is get rid of the negative exponents. So you're going to leave the x to the 21st where it is. You're going to move x to the negative 2 down to the denominator and make it x squared. You're going to leave y to the 2nd on top because it's a positive exponent and that's where it was originally. Then you have an x to the 2nd in the denominator. That's another one. See, this is what made that x to the 2nd I've already written. Now I still have that x to the 2nd down there. And then y to the negative 14. See, that one's going to move to the other side of the fraction bar and become positive 14. Okay. And then what I usually do is go ahead and collect what I can, get the top as simplified as possible, And there's 1, 2, plus another 14 y's. That'd be 16 y's multiplied together. Denominator, there's 4 x's. And then I'm looking at that and noticing I can cancel out 4 of the x's. See, that's 4 x's multiplied together. I can knock out 4 of the x's from that string of 21 x's, and that's going to give me 17 x's on top and then y to the 16th. And that would be my final answer. Okay. All right, so 4-1, 4-2, those were the exponent type problems. And then I'm going to go ahead and look at 4-3 as well. That was the one that dealt with scientific notation. We actually did it first. Okay. Okay, so you should be okay with number 15 and 16. I won't take our time up there. Thought we'd look at 17 and 18 here. And then I'll stop the video and do another one on the next couple sections. All right, so with 17, we have 16.8 times 10 to the negative 1, and that's over 4 times 10 to the 8th. And then on 18, I have 2 times 10 to the 8th, and then 7 times 10 to the 8th. Okay. All right, so the intent of these is that you would take the 16.8 divided by 4 on your calculator. If you did, it would turn out to be 4.2. And then this, I don't like rules typically, but here's where it really is best just to use the rule. So we have a quotient. We can subtract those. We could do -1 minus 8, and we'd get 4.2 times 10 to the negative 9th power. 4.2 is between 1 and 10, so that would be our final answer if they wanted it in scientific notation, which they did. All right, and then with this one, this is just really all times here. And so we can just do the 2 times 7 and get 14, and then 10 to the 8th and another 10 to the 8th. That would be a string of 16 tens. This one's a little harder because the 14 is not between 0 and 1. So we'd have to come in and move the decimal, which is there, to here. So we need this one to be 1.4. See how I had to move the decimal once and I made it smaller? So I'm going to compensate by adding 1 to the exponent and make it 10 to the 17th power. All right, another way to see it is 14, which is what I originally had. Remember that was 14 right there? That's the same as 1.4 times 10. And so another way to see the 17 is to realize I just put the 10 to the first from here together with the 10 to the 16th. I just use a little shortcut when I do it, and I thought I'd share it. If I have to make the number smaller by moving one place, then I compensate for that by adding 1 to the exponent. If I had to move it twice to make it smaller, then I would add 2. And then if I had to move it to make it bigger, to get it to be the size I needed, then I would subtract from the exponent, okay? All right, so that should be your answer on this one, okay? So let's say you had, 0.025. This is what happened after you did a problem. This is a what if. This is not on the sheet, okay? And you need to fix it. It's like it's not either form. What you would think to yourself is, well, here's where the decimal is, and here's where it needs to be. So it needs to be moved 2 places, and I'd be making the number bigger, wouldn't I? So I'm going to compensate for that by taking 2 away from that power of 10. So that would be times 10 to the 6th power, okay? All right, and then if you wanted to see it in a different way, if that didn't make sense or you don't like shortcuts, you can think, well, 0.025 is the same as 2.5 times 10 to the negative 2 power, and then you could put the negative 2 and the 8 together and get your 6. Okay, so that was a what if. That was not a problem on the sheet. Okay, so I'm going to stop this video here. That covers sections 4.1 to 4.3, just selected problems from the review I passed out on Wednesday. And those 3 sections had involved problems with exponents in them.